are going to discuss some practice problems on arc length, right? Let me write that. Practice problems on arc length. Right? So let me draw a diagram, right? So here you get a semicircle, and the radius is 7 centimeters, right? And as you know from my early videos, you can always go to my early videos. The link to those are in the description box. And you know that this is the arc. And this entire length from, let me mark this point as A and this point as B. The length from A to B is the arc length, right? Arc length. So what is the arc length of this sector? Of this sector. A sector is a region with an arc and two radius, right? So you can go to my early videos, right? So in order to find the arc length of this, I have to use an equation. So this is 180 degrees enclosed by this semicircle, and let me write the equation for that. I'll take the arc length as L, right? I'll represent it as L, right? L equals theta over 360 degrees 2 into 2 pi r, right? So this is the equation that we use to find the arc length. You can go to my early videos to check the method to derive this equation. From this video I take this because I know how to derive this. I take this for granted. You can go to my early videos to check the method to derive this equation, right? So L 180 degrees divided by 360 degrees into 2. The value of pi is 22/7. You can check this in my early videos. And the radius is 7 centimeters. The units come in centimeters, right? So half, when you divide this, get half into 2 into 22/7 into 7 centimeters, right? So you can divide 7 by 7. You can divide 7 by 7, then 1. You can divide this 7 by 7, then it's 1. Can likewise you can divide the 2 and get 22 centimeters, right? So this is the answer. Half, you can divide 180 by 180, then you get 1 here. You can divide 360 by 180, you get half, you get 2 here, into 2 into 22/7 into 7, right? You get 22 centimeters, right? Let me work out another example. I will list this. We take this, right? So this is another segment of a circle. This is quarter of a circle. You have 90 degrees angle here, and this is the arc, right? This is the arc length. So we are interested in finding this, right? So A to B, and again I will mention this as L1, right? So this length is L1, right? How do we find this length? The length L1 represents the length from A to B. Again, I'll show that for you. This length, right? So this is the length from A to B is the arc length of this sector, right? Right, let me write that for you. L1. Again, I use that equation. Theta over 360 degrees into 2 pi r, right? So here theta is represented by 90 degrees. So this is an unknown angle, but in this instance I know that this angle is 90 degrees. So I'm going to use that here, 90 degrees, and 360 degrees into 2. The value of pi is 22/7. I did use a radius, sorry for that. I can use this again as 7 centimeters. You can take anything, but in this instance I use it as 7 centimeters. 7 centimeters. I can divide 90. Let me show how to divide this, right? So you have the fraction here. I divide 90 by 90. Yes, I divide 90 by 90 degrees, right? Then I have this part here. So this shows the numerator. I divide the numerator by 90 degrees. Then I divide the denominator by 90 degrees. So this is how you divide it, right? And rest of this, I have this equation up here. 22 upon 7 into 7 centimeters, right? So I'll take this part up here, right? I'm going to take this part up here. Right, when I divide this, I can divide 90 by 90, and I get 1 here. 1 upon 1 is 1. When I divide 360 by 90, it's 4, right? That's a quarter, right? 1 and 4 here. I have the 2 here. I have the 22 upon 7 here, and the 7 centimeter, right? So this comes in centimeter, right? Now I can divide again 7 by 7, and I have 88 upon 4. That is going to be I have 44 upon 4. Sorry, I have 44 upon 4. There you go. I get the arc length as 11 centimeters, right? So these are how I get. I use this equation for theta. My angle, the angle is represented here in this instance. The theta is represented by 90 degrees. 90 degrees over 360 into 2 pi r. If I solve this, I get this, right? So let me list this as well. Okay, let me take another example. Right, it doesn't look very neat, but alright. And this is 120 degrees. This is A and B. So here I have my arc here again, arc length. Here you just use this as C, right? So C is my arc length. Again, I can use the equation. Let me take the radius as 14 centimeters, right? 14 centimeters. The arc length C is theta over 360 degrees into 2 pi r, right? So what's theta here? 120 degrees divided by 360 degrees into 2 into 22 upon 7 into my radius now is 14 centimeters, right? And again I can divide this as usual. I can divide this 120 by 120, right? And I can divide this 360 by 120 again, right? And I have the rest of my equation in this side, right? 2 into 22 upon 7 into 40 centimeters, right? So I take it here. So it's neat, kind of neat, yeah. I can divide this 120 by 120, I get 1 and 1. I can divide 360 by 360 by 120, I get 3 here. So 1 over 3 into 2 into 22 upon 7 into 40 centimeters. Every time you need to use the units because you get the radius in centimeters, so you get the arc length in centimeters, right? So I can divide this again. I can divide 14 by 7, I get 2. I can divide 7 by 7, I get 1 here. And then I have how much I have? 88, right? Isn't it 88? Yeah, I think it's 88. 22 into 2 is 44 and 82 is 88 over 3 centimeters, right? So you can take as a decimal. So I leave it as a fraction here, right? So another example as the last example, right? Okay, let me use this as an opportunity to do my last practice problem on arc length, right? So here I will use so this is kind of, yes, I'll do it this way. The best thing is to take an angle like this, right? So this is same thing, this is an angle of 45 degrees. So this is my arc again. Arc, I mark this as point C and D, arc length or distance from C to D. Distance from C to D, right? So that, to get that, Again I use my equation. I'll write length of CD theta over 360 degrees into 2 IR, right? So for this I have for theta I have 45 degrees over 360 degrees into 2 into 22 upon 7 into, sorry I missed the radius, right? So let me write the radius as, right, let's see, I put 21 centimeters, right? So here it's 21 centimeters, the radius R represents 21. Yes, I can divide this by 1, and for 360 I have 8, if I'm right, isn't it? Should get 8, right? Is it? Let's see, I divide this by 45 degrees. I can divide 45 degrees by 45 degrees, can leave it like that. I can divide 360 degrees by 45 degrees, right? So that is, I get 1 here, and yes, I get, you have, now for 9 you have 2, and yes, you have 8, right? So you have 8 here, I put it here, so 1 over 8, or let me write it here, sorry, let me write this here. You have 1 over 8 into 2 into 22 upon 7 into 21 centimeters, right? So you can divide 7 by 21, you get 3 here. This I use the same principle, I can divide 21 by 7. If you want, I can show that as well, right? Let me show that for you. Okay, 21 here, right? So I have a fraction here. I have this fraction, I can modify it, right? I can take this 7 here, right? So this is what I'm doing actually. Let me show that to you here, right? And same thing, I can divide 21 by 7 again, and 7 by 7. So this is shown here, right? The same thing I do. This is, right? I can divide 7 by 21, I get 3 here, 1 here, and I have I can divide 2 by 8, I get 4 here, and I have 66 over 4. I can multiply 22 by 3, that's 66 divided by 4 centimeters, right? So this is the length of CD, right? So that's it from this video of practice problems, right? Thank you.